Okay, we are live. Okay, so what we're talking about is how do you know it's a parallelogram? So what are the characteristics of parallelograms? And we said two sets of parallel sides. But not only do we know that they are parallel, what else do we know about those two sets of sides? They're not just parallel, but they're also... Does anybody know? Huh?
Next to each other.
Well, I mean, that's, shape. They're also... They're congruent. So you've got two sets of parallel sides that are also congruent to each other, right? Like, not the sets are congruent, but the sides are congruent in a set. So the ones that are across from each other are congruent to each other. Okay, what do we know about the angles of parallelograms? What's the same? Which ones? All of them?
No, two of them.
Which two?
Two sets.
They have two sets of angles that are the same, but which two sets? Like, across from each other. The ones that are diagonal from each other, right? So the diagonal, I can't spell diagonal. I don't think that's right, but we're going to go with it, okay? Somewhere, right? Where does the A go? Diagonal. Is it O-A-L?
I don't know. What are we doing?
I don't know. We're going to work.
Are we still working on the shape?
Yeah, I think I printed yours, and I think it is too small.
It is.
I think so.
So it doesn't matter.
We'll look at it when we get down there, okay? Okay, diagonal angles are congruent. Okay? And then we know that the angles that are not diagonal, the ones that are consecutive, so the consecutive angles are what?
Supplementary.
Right. Good guess on your part, reading what I'm writing. Okay? So we know that the sides are parallel and congruent. We know the diagonal angles are congruent and consecutive angles are supplementary. What do we know about their diagonals? Not the angles, just the lines that are diagonal. This still don't look right. But anyway, what are the we're going to go with it. We can all know what it says, right?
I don't think you put an O.
I think it has an O.
I'll give it an A.
Oh, y'all know what? Diagonal.
That still don't look right.
I don't know. We're going with it, okay? Whatever. Okay, if we did not know I can't spell, we do now, right? Okay, the diagonals. That's the lines that go across the shape. What do they do to each other? The lines that go across the shape, what do they do to each other? You know, we've got this parallelogram, right? And we've got this, and we've got this. What do they do to each other? They do, but in a special way. They bisect each other, right? They bisect each other, which means they have the same midpoint, right? Their point that's in the middle is the same for both of them. Y'all with me so far? Okay. We're going to use this information today to prove that shapes are parallelograms, or to prove they're not, or to say they're not. Okay? So you got your 6-3? I don't have my 6-3. Where's my 6-3 for y'all? Nope, I'll just get one.
Can I have it back though?
Nope. What's up?
Nothing. Miss Ryan, I'm filling out my housing application today. Cool. No, I'm nervous.
Oh, please sit you.
Be very, very honest with yourself when you're doing that.
What do you mean honest with myself?
Well, like I put that I wanted to be on the quiet floor. I was the oldest of 6 kids. I've never had a quiet household in my entire life. Quiet floor was a bad place for me. Couldn't focus at all.
I think I'm going to stay in town for acne, so I think it's going to be cool.
Okay. Let's look at number 1. What information did they give us on number 1? What did these little lines indicate? The little notchy marks. That doesn't mean parallel. That means congruent. Now the little arrows, hey y'all, the little arrows mean parallel. but the little lines mean congruent. Well, if these two are parallel and they're congruent to each other, which means they're going at the same angle and they're the same length, right? Then that means that these up here also have to be parallel and congruent to each other, right? So, what's our answer for this? Is it a parallelogram or not? Yes. So our answer would be yes, it's a parallelogram. And our reason would be it has two sets of congruent parallel sides. Okay? Look at number 2. What information did they give us? What do those little lines represent on those angles? So, these are congruent and these are congruent. So, since the diagonal angles are congruent, what do we know about this shape? It's a parallelogram. So, our answer would be yes. And our reason would be it has two sets of congruent angles that are diagonal to each other. Okay? When on your practice page, there are boxes that say yes and no, and you'll select yes or no, but then you get to type your reason in. Okay? If you don't type your reason in, I will count it wrong. Number 3. What information did they give us? So this just says that they're congruent. Are they parallel? We don't know. They could be, but they didn't tell us that they are. So we don't know that for sure. So y'all, we could have one line like this and one line over here like this. Now, that's clearly not what they look like, but it could happen, right? Just these two being congruent does not make this a parallelogram. So what's our answer? No. And what's our reason? It doesn't meet the criteria to be a parallelogram. We don't know all the information. We don't know enough information, right? Okay, now look at this one. This time they told us these are congruent and these are congruent. Bless you. So if they're both congruent, does that make it a parallelogram? Yes. If you have two sets of congruent angles, then yes. Congruent sides, then yes, it is a parallelogram. Okay, everybody good so far? That's pretty simple, isn't it? Just determine, is it a parallelogram or is it not? Based on the information, not based on what it looks like to you. You have to base it on the information they give you. Okay? Now, you should have a piece of graph paper. You got it? Graph the points from number 5, because we're going to talk about it, but we need to graph it first. So get it graphed. And make sure you label them like P, Q, Okay, so this is what you should have. You got it on there? Okay, so on number 5, they tell us to determine if it is a parallelogram based on the method that they gave us. So what does it say on number 5? What method? Slope formula. Now let's talk about what slope formula does for us. If we find the slope of the segments, how do we know if lines are parallel or not? Parallel lines have the same slope, right? So if we find the slope of the lines and it's the same, then we know that those lines are parallel. If we have two sets of parallel lines, then we know it's a parallelogram, right? We don't even have to do any math for these two because they're horizontal lines. And what do we know the slope is for every horizontal line in the world? Not 2. 0. Every horizontal line in the world's slope is 0. And both of those lines are horizontal. So we can... No. No, you wasn't. Okay, just because it's numerically close doesn't make it a close answer. Okay, now we need to find the slope for the other two. We can use slope formula or we can count it. Since we already have it graphed, let's go ahead and count it. Okay, so to count it, we're going to go up 1, 2, 3, 4, and then over 1, 2, 3. So the slope of PQ is 4 over 3. And then if we do the slope of YS, right? We go up 1, 2, 3, 4 over 1, 2, 3. So our slope is 4 over 3. So what did we discover? They are also parallel. So is it a parallelogram? Yeah, it's a parallelogram. So our answer would be yes, it is a parallelogram because QS is parallel to PY and PQ is parallel to YS. And so since we have two sets of parallel sides, then it is a parallelogram. Okay? All right, graph number 6.
Miss Martin,
Yeah.
this class is like the quietest class out of all your classes.
Yeah, they are. Yeah, absolutely.
All the classes are so loud.
We say we're loud. No.
I've never said door aloud.
Some people in the back.
No, now, having said that, I do have 2 girls gone. And these 2 girls that are gone and Anthony talk a lot. But they're not loud. They're just annoying. And so I have to occasionally tell them to shut up because
Kinda like me, Wendy,
they talk
and
too
Luke
much.
In our class.
Huh?
Kind of like me, Wendy, and Luke in our class.
Yes.
Aw, I miss that class this morning.
Okay, y'all graph number 6, okay? Graph number 6. Make sure you label your points.
I'm gonna go back. I've been in the bathroom too long. This time,
I'm gonna email your teachers and tell them quit letting you go to the bathroom.
no, I go every class period.
I know you do. Because you come by here every class period. Bye. X is horizontal, Y is vertical. X goes this way, Y goes the other way. Okay, this is what you should have. Well, then you did something wrong and you need to fix it. Okay, now on this one, what method does it say to use?
Distance and slope.
Distance and slope. Now, what would distance get us? If we use the distance formula, what could we find with it?
2 kilometers. Something like that.
What could we find in this problem? Distance between 2 points, which would be what on the parallelogram? What would that be? If we find the distance between S and R, what are we finding on the parallelogram? Y'all got nothing? Y'all making this harder than it is. If I find the distance between S and R, what is that on the parallelogram?
4.
No. I'm just asking for words, not a number. The distance between S and R is going to be what on the parallelogram?
To the
So-
right.
It's gonna be slope.
No, it's not slope.
To the right.
How about the
Like right. Like this way.
It's how long the side is. How long the side is. That's what it is. The length of the side. The distance between S and R would be the length of SR. Y'all making that too hard. Okay, now how do we find distance between 2 points? Y'all remember this guy?
the distance from the
Uh-huh.
Oh yeah.
Remember this?
Kind of like.
Okay. So if we're finding the distance of SR, we would do -2 minus 1 squared. That's this x and this x, right? And then we would do 1 minus 3 squared. That's this y and this y, right? So -2 minus 1 is -3. 1 minus 3 is -2. What happens when you square a negative? What do you get? Positives. It's going to be 9 and 4. What's 9 plus 4?
13.
13. So this length is square root of 13. Now we need to find the length of this one, right? So we'll find the length of ZT. So to find the length of CT, we're going to do the exact same thing. So distance is going to be, I know you can't see it. I'll show it to you in a minute as soon as I get it wrote down. Z.
Pardon the interruption. The Quizbo trip to Fayetteville on Saturday has been canceled. Thank you.
So this is what your distance should look like on the second one, on ZT. We're finding the distance of ZT, right? So that's going to be -3 squared again. That's going to be -2 squared again. Sound familiar to you? So what's that going to wind up being? What's -3 squared?
Well, it's gonna be -3. I mean, positive 6.
Positive
5, 6.
9?
Oh yes. Oh,
-2 squared.
4.
4. What's 9 and 4? So it's going to be square root of 13 again. Okay, well, we know that those are congruent. That doesn't prove they're parallel. Can we prove they're parallel?
Yeah.
How do we do that?
The 13.
That doesn't prove they're parallel. What would prove they're parallel?
It's a square, so that all the sides are the same. Right?
We don't know if it's a square.
It looks like a square.
We don't know that. What thing can we find to know they're parallel? Slope. We can find the slope. So we just go up 1, 2, over 1, 2, 3. Is that 3? Yeah. So it's going to be 2 over 3. And then this one, up 1, 2, over 1, 2, 3. So this one's also 2 over 3. So these two are congruent and they have the same slope, so they're parallel. So that means, what about these two? They have to be congruent and parallel also. Y'all see what I'm saying? So our answer for number 6 would be yes, because they have the distance of SR. Okay. What about number 7? It's asking you to find the midpoint. So go ahead and graph number 7 for me.
So it's like 2, 5. It's 5, 2.
2, 5 is 2, 5.
Yeah, but when we graph it, it's 5, 2. Right?
No, when you graph it, it's still 2, 5.
On the y-axis,
Your x is 2, your y is 5.
the axis is the one going down, right? I think so.
X is the one going sideways.
Yes, I'm talking about the one on the bottom.
It just occurred to me, you don't know what you're doing.
The bottom left corner is negative.
This is what it should look like. Something like this. Actually, I think I have this one wrong. I think I did that again. Did the exact same thing last period. What's that one? -3, 1. -3, 1. Okay, look, Jonathan. Negative 3, 1. Look at the screen, Jonathan. Look. Negative 3, 1 would be negative 3, positive 1. Remember, this right here is your x-axis. And in a point, x is your first number.
I got like a square.
This is your y-axis. And this right here, y. Okay, it should look like this. Which, by the way, just looking at it, is that going to be a parallelogram? No. But we need to prove it's not. So to prove it's not, in this situation, they want us to use midpoint, which means we're dealing with diagonals. They want us to find the midpoint of both diagonals. If the midpoint of both diagonals is the same number, it is a parallelogram. If the midpoint of the both diagonals is different, it's not a parallelogram. Okay? So, how do you find midpoint? Do y'all remember how to find midpoint? Nope, you're making it hard. Uh-huh.
Yeah, x plus y
XX.
plus y.
X plus x divided by 2, right? And then y plus y divided by 2. Okay, so we're going to find the midpoint from here to here, right? And then we're going to find the midpoint from here to here. I'm not going to look at the graph because that's hard for me. I'm going to go look at the paper. So we're going to find the midpoint from WY. So the midpoint from WY, so W to Y, is going to be 2 plus negative 2. I just did that wrong. 2 minus negative 2 divided by 2. Now what happens when you minus a negative?
It's a positive.
Right. So, oh, yeah, that's right. That's 4. Is that right?
Yeah.
So that's 4 over 0, right? What is 4? I mean, 4 over 2. What's 4 over 2? 2. And then we're going to have, for the y values, we're going to have 5 minus negative 3. Right? What is 5 minus negative 3? 8. What's 8 divided by 2? 4. That's not right. What did I do wrong?
Then we added 8. I think it was at 8.
Oh, because I'm so tracked. What? I've lost my dang mind, y'all. This right here. It should have been 2 plus negative 2. And this should have been 5 minus 3. What am I doing? No, plus negative 3. 5 plus negative 3. So this would have been 0, which means that would have been 0. And this would have been 1. You should have said something. Sometimes my brain just quits on me for some reason. It just does it. Okay? Alright, so that's WY. Then we got to do RN. So the midpoint for RN. So the midpoint for RN, we're going to do 3 plus negative 3 divided by 2. And then we're going to do 3 plus 1 divided by 2. So 3 and negative 3 makes that 0. 0 divided by 2 is 0. Oh, it looks good so far, don't it? But then look here. What's 3 plus 1? 4 divided by 2. Are these the same? They are not the same, which means they don't have the same midpoint, which means they don't bisect each other, which means it's not a parallelogram. Not a parallelogram. Huh?
I know from the beginning.
Okay. Those bottom 4 right there is exactly the same stuff we was doing yesterday. Exact same stuff. The only difference is yesterday they said these are parallelograms. Solve. And today they're saying, oh, what would X and Y have to be if these were parallelograms? It's still the exact same math. You're doing the exact same thing. It's just given to you in a different format, where before they were saying, hey, I know these are parallelograms, just solve and tell me what X and Y are. And today they're saying, so we've got these shapes and we just want to know what X and Y would have to be for these to be parallelograms. We're not saying that they are parallelograms, but we want to know what X and Y would be if they were parallelograms. Do y'all see the difference? You're still doing the exact same math. You're assuming these are parallelograms, so you're assuming these two sides are congruent. So you're going to set up an equation where they equal each other. Same thing here. You're going to set up an equation where they equal each other. Solve for X, solve for Y. Those are the values that would take to make those parallelograms. And then same thing here. 3x is going to equal 4x minus 3. Y plus 3 is going to equal 2y minus 11, because we're assuming, hey, they could be parallelograms, and this is what values would make them parallelograms. You'll see what I mean? Same math. I hate when they do it like that, where they're like, so we're not going to say they are, but if they were, what would X and Y be? That's what they're really doing right here. Okay? They're not saying these are parallelograms. They're saying, what if they were parallelograms? Do you see? Okay. All right. So that's it for 6.3. So y'all can go ahead and start working on 6.3. I'm going to end our video and post it. And then tomorrow, 6.3 is your assignment. On Friday, there will be a video for 6.4, a short video. I'm going to keep it real short. And you will be responsible for 6.4. 6.4 will be posted on Google Classroom. It will be interactive. You will need to work on paper and then post a picture of your work. Okay? That's for Friday.
We don't have any.
Then you'll have to finish it when you come back to school, but you're not going to have class time to do it.
Yeah, my internet wasn't working.